We're going to start on P2.
God. Speaking of
Okay. We finished the front side. We're ready for the back side. Am I correct?
See.
Okay. So, on the back side, this is actually something that did not come, we don't do in our Algebra 2 curriculum. It does go along with the Algebra 2 curriculum some places, but I tend to do this more with the pre-calc curriculum. So, we're going to talk about standard equation of a circle. So, this form right here, x minus h quantity squared plus y minus k quantity squared equals r squared, is formula for a circle. If something's in that form, I know enough that I can look at that and be like, oh, hey, I know that's a circle and I know it's located here and has this information. Now, before we get into this, a little bit of information you need to know. What's R going to stand for in a circle?
Radius.
Yeah. R stands for the radius of your circle. And the other piece of information I know by looking at this circle, the numbers that will be in place of h and k. So the ordered pair HK is the center of your circle. Okay? Other than that, it's filling in H and K, the center of your circle, so you know where your circle's located. It's filling in R for the radius. Other than that, the X and Y stay there, and you have an equation of a circle. So, pretty basic. Don't make it more difficult than what it is.
So what's the X and Y for?
They're your variables. They're your part of the equation.
That's how you find them.
Like if you're graphing y equals mx plus b. We fill in m and b, but we leave x and y as your variables. So if we look at this one, the center of 4, -1 and a radius of 8. Well, that means 8 is going to go in place of R. 4 and -1 are going to go in place of H and K. So if we start filling this out, because all we're doing is just trying to write standard equation of a circle, parentheses, x minus, what's h? 4, quantity squared, plus, parentheses, y minus, what's k?
-1, y plus 1.
Okay. Officially, y minus -1, yes, I'm going to change it in the next step to y plus 1. Quantity squared equals r squared. 8 squared. Now, this isn't exactly the form I'm going to leave it in, but this is pretty close. Okay, I'm going to clean up a little bit. So, I'm going to have x minus 4 squared, y minus -1. As Logan mentioned, that is the same as y plus 1. Quantity squared equals, and what do we know about 8 squared? 64. And that's where I'm stopping. We're not doing any fancy work. We're not getting all crazy with this. But right there, I know it's the x squared plus the y squared term equals a number. I know that's an equation of a circle. I can look here and be like, oh, this is 64, so that means my radius is 8. And then I know this circle from the center, the x, it's going to move 4 over right, and it's going to move 1 down. Okay, I know that just by looking at this equation. So let's do one other here. C, a center of 0, 0, and a radius of 5. What do we know?
Well, it's really just going to be x plus y.
Okay. My h and k are both going to be 0. My radius 5. If I write this out the long way first, x minus, what's h?
0.
0 squared plus y minus 0 squared equals
5 squared.
5 squared. Now, that's kind of pointless, right? We don't need x minus 0 and y minus 0. X minus 0 is going to be x, so x squared plus y squared equals 25. Okay, that's what I would leave for equation of a circle. And again, when I see an x squared plus y squared term, I know that's a circle. In this case, since there's no numbers with x and y added or subtracted to them, I know that it's centered at 0, 0, and it has a radius of 5. Okay, again, we're just learning the basics here, but you got it?
Yes.
Okay, we got another one here. It asks us to write this information as an inequality. And the statement is the distance between x and negative 3 is less than 9. Any thoughts?
Skip it.
Vetoed.
Skip it twice.
Vetoed twice.
What do you think?
I think
Yeah,
I wanna
she's
talk
asking
about-
us 'cause she needs help. What do you think?
Okay. Place to start.
D.
Distance. We talked about distance in one of our definitions on the front side of the notes yesterday. It's not written on your notes, but we talked about in relation to one of the concepts on the front side of the note. When we talk about distance in math, distance is part of the definition for, I think how to hint this, and I don't know.
Are you one of the formulas for distance?
Well, if you look at one of the formulas for distance, what's around that formula?
Absolute value.
Absolute value, right? What is the definition for absolute value? The distance from 0. Okay, so when we talk about the distance between x and negative 3, we're going to use absolute value to represent that. Okay, so when it says distance, that tells me, okay, I'm going to think absolute value. Distance between what?
X and negative.
X and negative 3. So the distance between them, I'm going to say x minus the negative 3. So that right there, the absolute value of x minus negative 3 is expressing the concept of the distance between the two values. Because to find the distance between two things, you subtract them, right? And then it says what?
Less than 9.
Less than 9. So what am I going to say?
Less than 9.
Less than 9. Okay. There's a smidge of cleanup in that minus a negative is the same as saying x plus. So we can say the absolute value of x plus 3 is less than 9. Okay, so just kind of introducing the idea of writing the inequality with absolute value there. Okay. Our bottom section. The bottom section is going to go back and we're going to talk about distance formula and midpoint formula a little bit, kind of examples of way to use those. So the top one, use the Pythagorean theorem and the distance formula to show that these three given points determine a right triangle. Okay? Now, are we processing what they're wanting us to do here?
Determine the right triangle.
Okay, I mean, we basically determine a right, we're trying to prove that these 3 points are a right triangle.
Hear me out. We just grabbed it.
Well, but does that prove it's a right triangle?
Then we measure one of the corners.
I mean, because I'll be honest, I am going to sketch us a graph here.
Heck yeah.
Okay. Just so I have the visual, negative 3, 4. There's negative 3, 4. 1, 0. And there's 5, 4. Now, maybe that looks like a right triangle to you. Maybe it doesn't. But our job is to use the Pythagorean theorem and the distance formula to show that it is a right triangle. Now, Logan talked about measuring after we graph it. Well, this isn't exactly drawn to scale. This is a little sketch. I can't measure each side. What can I do?
You can throw them in the Pythagorean theorem.
Oh gosh, I have a feeling I know what you mean.
We're not going to throw them in the Pythagorean theorem yet.
The distance formula first.
We have to throw them in the distance formula and find the
Distance between every single
the length of the three sides, and then we'll take those lengths of the three sides and throw them in the Pythagorean theorem.
So we're gonna do distance 3 times.
Yes.
I'm gonna cry.
I quit.
Seriously, guys? I put a little bit of work. This is not even hard. This
Yeah.
is not even hard. This is more the annoying type of work.
This is more work than we do at soccer.
Definitely not.
Oh yeah, you're right.
Okay, let's pick 2 points.
-3 and 4 and 1 and 0.
-3, 4, 1, 0.
Yeah.
Okay, so distance formula.
It's x2 minus x1 squared plus y2 minus y1 squared.
Okay, so x minus x. So I said 1 minus -3 squared plus y minus y, 0 minus 4 squared. 1 minus -3, 4. So 4 squared, 0 minus 4, -4. 4 squared is 16. -4 squared is 16. I have the square root of 32. I'm going to leave it as a square root of 32. You can come up with a decimal if you want. Here's my thought. I'm going to leave it as square root of 32. I'll come up with a decimal later if I need it. But I'm going to tell you, you won't need it.
So wait, what one is that?
So that was -3, 4 to 1, 0. So that is that one right there. Yes?
Yeah.
Okay. Let's do another one.
3, 4, 5, 4.
-3, 4? 5, 4?
Yep.
Okay. Square root of x minus x, 5 minus -3 squared, plus y minus y, 4 minus 4 squared. 5 minus -3, 8 squared. 4 minus 4, 0 squared. Square root of 64, which is 8. Reality. No one called me on it, so I went with it. Did we have to use the distance formula here?
No. Gosh dang it.
Huh.
We could have just counted.
They were on they're on a horizontal line. 3 left and 5 right. They're both on the 4 line.
As a teacher, aren't you supposed to point that out to us?
She did.
I'm sure we did.
Yeah, I get it. I'm saying.
I was hoping someone would point out before. Okay, what else do we need to find?
1, 0, 5, 4.
1, 0, 5, 4.
This is stupid.
You guys are a bunch of complainers.
Yeah, yeah.
Okay, x minus x,
Crap, 1, 2.
5 minus 1 squared, y minus y, 4 minus 0 squared. So 4 squared and 4 squared. 16 and 16.
Square root of 32.
Square root of 32.
Yeah.
It is right triangle because of the 45, 45, 90-year-old.
Attaboy.
Ooh, I haven't even talked about trig yet.
Ah.
You remember some geometry there?
Oh,
Okay. What I'm going with here, let's check the Pythagorean theorem out. What is my Pythagorean theorem?
A squared plus b squared equals c squared. Or 45, 90.
yeah, 45, 45. You just right.
I'm going to use Pythagorean theorem because I don't remember if the one in homework works that way or not. But okay, Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. What are my 2 legs?
Square root of 32.
Yeah, the square root of 32 is less than the square root of 36, so it's something less than 6. So I know those are the 2 shorter sides, right? So I'm going to do square root of 32 squared plus square root of 32 squared equals 8 squared.
Wouldn't it?
Well, what happens when you square a square root?
Cancels.
When you square the square root of 32, the square and square root cancel each other out.
So
32 plus 32 is equals 64. What is 32 plus 32?
64.
So once we come up with that statement that 64 equals 64, that is my proof that it
It's a right triangle.
is a right triangle. Okay, so that's a way. Finding those distances, okay, we can't measure them, okay, but we use our distance formula, and Pythagorean theorem is our proof that it is indeed, the sides do make sense in the Pythagorean theorem. Are we okay with that?
Yeah, I'm okay with stopping there too.
Last problem. Use the fact, so a little more geometry for you. Use the fact that the diagonals of a parallelogram bisect each other. Now, do you remember the word bisect?
They cross.
They cross how?
Equally, like this center is like, it's the center for both of them where they cross.
Okay, when they bisect each other, they're cutting each other in half. Okay, if something bisects something, it's cutting it in half. So if they bisect each other, those diagonals are cutting each other in half. Okay, so use that fact that the diagonals cut each other in half to determine whether the points AB, A plus C comma B, 0, 0, and C 0 make a parallelogram.
There are more letters and numbers. You know,
Could one line technically bisect just one line? So like, could technically line A bisect? Like, does that make sense? No, never mind.
I'm not following you,
I'm
so
not following
I
you
don't
either.
know.
Never mind.
I'm not going to tell you it doesn't make sense because I'm just not following you.
No,
So,
never mind. You're-
okay, so here's the deal, guys. We use distance formula here, right? If we're talking about two things bisecting each other, cutting each other in half,
Midpoint.
we're trying to find the midpoint. So the idea is if these 4 points truly make a parallelogram, and that the diagonals bisect each other, they're going to cut each other in half, and the midpoints of those two diagonals should be the same. Now, yes, we're working with variables. You can do this. It is doable. Okay.
Are we doing it twice? Just the midpoint formula twice?
You'll have to do the midpoint formula twice.
Not 4 times.
No, not 4 times. And we're going to kind of draw this. Okay. You obviously see 0, 0. There's 0, 0. Okay. We have the point C0. So C0 is going to be
Something.
right C, up or down 0. So I'm going to put C0 over here. Fair enough? Okay, C is it's a variable representing some number. Now, we also have A comma B.
It's going to be somewhere on the graph.
Okay, so A comma B
Yeah.
means it has to go
Over 1.
right A,
Up B.
up B. Now, I'll explain why here in a little bit, but A has to come before C. And you'll see why when I get to the next step, okay?
Does it not just because A becomes before C in the alphabet?
I guess maybe it doesn't have to. I'm going to put it there, but okay. So technically you arbitrarily put A somewhere here. So I'm going to make A here. I'm going to make B here. So where is the point AB?
Over 1.
Over A, up B. Okay, now, I guess technically A wouldn't have to come first, but
I have a feeling I know where you're going with this, but since the next one is A plus C, it means it has to be after C.
okay. So now, the other point I haven't graphed yet is A plus C comma B. So it's going to go right so many. It's going to go up B, so it's going to be on the same level. A plus C, well, here's the distance of C, yes? Going A farther means I have to go
Somewhere past.
past, I have to go basically this distance right here that is A. I have to go that distance past C. And then I'm going to go up to B. So that point right there is A plus C, comma B. And I guess technically A doesn't have to fall before C. It just makes it a really long parallelogram if I don't.
So wait, and then if A fell after C, then it would be taking the distance.
It would just be an extra long parallelogram, but. Okay. So we have a parallelogram here, yes?
Yeah.
We are trying to use this fact to prove that they bisect. So now, diagonals, what are diagonals? They go from one corner to the opposite corner. One corner to the opposite corner. What point am I trying to find here?
Very mid.
Try to find that middle point right there. Maybe I shouldn't have used that light blue, sorry. But I'm trying to find that middle point. That's going to be where they bisect each other.
I got it.
So, we're going to do two midpoints. What's one midpoint we're going to do?
A, B, and C, 0.
Okay, so one midpoint is using the ordered pairs AB and
C,
C0. So do you remember your midpoint formula?
x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2.
Okay. You're adding your x's, divide by 2. Adding your y's, divide by 2. So if I add my x's, a plus c divided by 2. If I add my y's, b plus 0 divided by 2.
And it stays like that?
The only thing I could clean up, you might not have even written it, b plus 0 is
B.
b. So that's the only thing I'm going to change. So this is a plus c over 2, comma, b over 2. That's the midpoint going from AB
C,
to C0. Now, let's do our other midpoint. Now I need the midpoint going from
0, 0 to A plus C, comma, B.
0, 0, a plus c, comma, b. Same process, yes?
C.
So x plus x, so that's going to be 0 plus a plus c divided by 2. Y plus y, 0 plus b divided by 2. Well, do you really need the zeros there?
Nope.
No. So you end up with
A plus C divided by 2, comma, B.
a plus c divided by 2 and b divided by 2.
And they match, so yes, it is.
Okay. We just determined that the midpoints are the same. The midpoints are equal. So the diagonals bisect. Okay, that is the statement I can make. Midpoints are equal. So diagonals bisect. Okay. Okay. In your homework, page 17, it's all evens. 2 through 18, evens. 24 through 28, evens. Or you can write it as 24, 26, 28. And 38 through 52, evens. Make sure you start in the actual practices, not in the quick review or whatever it's called. And you have a little bit of work time. Use it. And there's a comment down there, areas of rectangles, triangles, and perimeters. These are things just going forward we need to know. Okay, I would like to think if I ask you area of a rectangle, area of a triangle, or how to do perimeter, you'd be like, well, yeah, I know that.
Yeah.